All right. Okie dokie. So let's go over this lab. It's a bit more interesting than last week's for sure. So besides having a few little problems, mistakes in it, we shouldn't have too much difficulty. So first things first, we're going to need to set up a network topology. Okay. So we have been given one router, two switches, and two PCs. So right off the bat, looking at this, we can already start to make some determinations on how it's going to be set up based on the IP address and the network that they fall into. So if we look at this, we're going to notice that there's going to be some commonalities between the IP addresses. In this case, we have our 10.10.10.2 for our IP address of the management VLAN, VLAN 1. For switch number 2, we have our management VLAN address of 10.10.20.2. You'll notice the subnet mask is a /24, which means then that the network portion is the first 3 octets in all of these, and the host portion is the last octet. So what does that all mean to us? Well, in the end, it means that we can sort of match up what side of the network these are going to go on. So for our one interface on our router, we can see that this switch 1 is going to be attached to it directly, and then we can see our PC1 is going to be attached to that switch because they're all part of the same network. On the opposite side of the router, we have our 10.10.20, we have our switch 10.10.20, and then we have our PC2 10.10.20. So those are all going to fall onto the same portion of the network. In order for the computers and for the switches, etc., to be able to talk outside of the local network, they do need to have a default gateway configured. And that's kind of where this extra bit comes in. And you can kind of think of the default gateway as sort of the method of getting outside the network. What is the address that if I don't have no knowledge of this network, where am I sending this data to? And in this case here, the default gateway is going to be the the router's port. So the router port would be 10.10.10.1. And then on the opposite side of the network, under the 10.10.20 network, it's going to be 10.10.20.1, which is going to be the other port here. So with that, we can start going ahead and adding that in there. So let's see, we're going to have a 1941 router, 22960 switches. We're going to drag those in, that's fine. Drag in our two PCs. We're going to have to add those in afterwards. We're going to have to name our devices. We're going to connect them. So we remember from the lab last week, straight throughs are going to be happening actually between everything because of the fact that the router one, hey, we can even look, it tells us actually in this lab how it's connected. So the one port is connected to the other port on the switch. The other port is connected to the other port on the switch. So instead of being on the fast Ethernet ports, they're on the gigabit switch ports. Makes sense since they're connecting the sort of the backbone between the two different networks. And our switch fast Ethernet is being connected to our other switch or other fast Ethernet on our PC. Going through our configurations, nothing really special. We're going to configure a host name, encrypt our passwords. We're going to configure Cisco as our console login password, as well as our remote telnet password. So we're going to have 16 connections set up for that. We're going to set up our message of the day, and then we're going to need to configure our 2 gigabit Ethernet adapters. And in there, we're going to add a little description, which is kind of interesting. It helps you sort of know where it's being connected to later on. As we continue through, we're going to do a copy running config. However, this is not the correct place that command will be run under, so we'll go to the right place to run that, because any thing that isn't a configuration, you're going to have to run from the enable mode. Continuing down, configuring switch 1, switch 2. So similar to last time, we're going to go through and we're going to configure our IP addressing, so that's fine there. We have the same thing that we do, enable secret class, so we're configuring our enable password, that's fine. Okay, oh, that because it previously was on the router. Okay, so these are for the switches, that's fine. We're configuring the default gateway for these switches so they can talk to the hosts on the opposite networks. That's all right. We're going to save our configuration. Same thing as previously. This isn't the right mode. So these commands would definitely fail if you tried to run them. We are going to configure our hosts, most importantly. And one of the things you're probably going to notice when you configure them is that the 10 network is what's known typically as a class A network. So it's going to want to give you a //8. So it's going to try to put you under just 255.0.0.0. Not correct. So we're going to have to correct that. Make sure that it stays in the correct network, which is a /24. The router or PC, it says, oh, you can leave the gateway blank at this time because there's no router attached to the network. Interesting. Yeah, you definitely can't leave the default gateway blank. So it's actually telling you here you can leave the default gateway blank, but I assure you you cannot leave the default gateway blank. But we'll actually play around with this afterwards, so I can show you how that would look. So with that being said, I'm going to drag the lab document off to the other monitor so it's out of the way. And let's go ahead and add in our routers. So it says it wants one 1941 router. Let's slap that puppy there. Let's go to switches. We need 2 2960 switches. Let's slap those puppies there. And if anyone has questions, feel free to just type them in the chat. Let me just close that thing so I can see this. Okay, we got 2 switches, and we need 2 PCs. So let's go to our end user devices, drag out PC there, drag out a PC there. Doesn't really matter where we throw them exactly, just got to get them in the right places. And let's give them some names. Easy enough. So let's change the display name on this. So we're going to go to the config tab. We're going to change this from router 0 to router 1. And I'm going to actually click those little top buttons so I can keep these off to the side and they don't hide on me. The switch, we're going to click, we're going to change the display name of the switch. We're going to change this to switch 1. Sounds good. Oh, I guess I should keep that open. Click the top button there. Toss that down there. This is probably going to get really cramped, but oh well. Click on the other switch, go to config, display name. We're going to call this switch number 2. And then we can click on the top button and sort of toss that right there for now. And then under switch 2, we're going to have our PC2. Same thing. We're going to change the display name on this, PC-2. Now let's go ahead and click the top button, and we can kind of hide this down here, over here for now. And click on that one. We're going to open it up, and we're going to label this one PC-1. And we'll click the top button there. And actually, we can even minimize these for now because we don't really need the PCs. So what we need to do next is we need to go ahead and connect up our network. That would be the most logical thing to do. So in order to do that, we're going to go to this little orange lightning bolt. We're going to grab our copper straight through connection. And we're going to go ahead and connect switch 1, fast Ethernet 01, to PC1, fast Ethernet 0. Grab that again. Do the exact same thing on our other switch. Fast Ethernet 01 to PC fast Ethernet 0. And then we are going to go ahead and grab our same thing again, going from the router. And we're going to go from 01 to the switch on its first Giga Ethernet port. And we're going to go from the other side of the router, Gigabit Ethernet 00, to the switch 01. So one thing you'll actually probably already notice right off the bat is that the switch port communication to the PC has come online, which we see with these green lights, green, green. However, on the router side, you'll notice the switch and the router side are red. And the reason being is because on a switch, the interfaces come online if you connect a device to them. However, if we highlight over this, you'll see the links are actually down. They're not powered up. Therefore, they're not going to function. So we have to bring them up. But before we bring them up, we got to do a little bit of configuration. Now, let's just see. Curious. Does it want us to use a console cable, or are we allowed to just go to the CLI? Record the PC addressing. We can just go to the CLI. Sounds good. So in order to go to the CLI, let's grab our router window. We can go to the CLI tab. And we click in the window and press the Enter key. Very similar to what you would see if you were running the terminal on a computer. It's just that you're running the CLI directly rather than having to manually wire in a console cable to one of those PCs. So we can go ahead and enter our enable mode. So now we're in the privileged mode, and then we can go to our global configuration mode by doing a configure terminal. Now we're dropped in here, and we can go to our set our host name. Host name for this is just simply router1, nothing fancy. We're going to go ahead and give it an enable password with the password enable secret class. And now we're going to go ahead and configure our console password as Cisco. It's one of those things you're going to get very, very used to. We're going to tell it that we want to use the login information. And here it has the exit, but as I mentioned last week, you don't actually have to type that in. It's kind of redundant. As long as you know what you're doing, you just type in line VTY015. So we're configuring 16 remote connections. Password, we're going to configure as Cisco, and then login. Fantastic. Next bit up, we're going to configure our banner message of the day. Simply just typing it in, MOTD. We use our delimiter character, which they're using here is the hashtag. I smack that in. I'm not going to type. I'm just going to paste. Bam. And notice what happens when we type in that command. It just drops us back to the config mode, so it's already entered in there. And if you want to see what's in there, we can do a little exit back to our enable mode. And if we do a show run, we can see here we got our enable secret. It's a type 5 password. we skim down our list. We have our 2 gigabit Ethernet interfaces, which currently are not configured, which is what we're going to be doing next. We also have our line consoles set up, and we have our VTY. Now, one thing, did it actually have the service password encryption, or does it do that later on? Well, it doesn't specifically say it, but it's definitely something we probably want to do. So let's go there and do that quickly. Config T, service, password encryption. We'll set that back up. And we'll go ahead and do our copy run start. So we're copying our running config over to our startup config. Bada bing, bada boom. And let's go ahead and configure our interfaces now. So back to global config mode. So configuration terminal, or short form config T. We can type in interface or just INT. Gigabit Ethernet. Oh, perfecto. And we're going to type in our description. Connected to switch 1 port G1/1. Is that actually what it's connected to, though? See that? Another mistake. That's kind of hilarious. It's actually not connected to G1/1. It's connected to G1 or O/1. Not that it really necessarily makes a difference, but interesting mistake nonetheless. So let's go ahead, do that. We're going to do our IP address 10.10.10.1 255.255.255.0, and then we have to bring our interface online. We do that with the command no shutdown. You'll see that our line state has turned on and our protocol has turned up as well. So we got up and up, and if you want to see if it's up and up, we can do a little exit. Now we're back into the privilege execution mode, privilege X mode, I guess you would necessarily call it. We can do our show interface IP brief. Show IP interface brief. Got it backwards. Show IP interface brief. And from here, we can see that we have our gigabit Ethernet 00. We can see our IP address has been configured, and it's basically up and up. And actually, let me just drag that so it's a little bit bigger so we don't get line wrapping. So it's up and up. That's what we want to see. And you can see the other interface does not have an IP address configured, and you can see it's administratively down, which means we got to bring it up. So let's go ahead and work on the other interface. So back to global configuration mode, we can do our interface gigabit Ethernet 0/1, and let's put in our description connected to switch 2 port G. Funny enough, same mistake as before. It's not 1/1. It's connected to 0/1 based on the instructions. So maybe it's something that was left over previously. We don't know. And let's go ahead. IP address 10.10.20.1 255.255.255.0. It gets pretty easy to ramble off in digits. Thankfully, it's all IPv4 and not IPv6. Because if you haven't worked with IPv6, IPv6 is hexadecimal, which means it's 0 through 9, A through F. So that can become a bit of a pickle to deal with. We're going to do our no shutdown to bring the interface online. We got our line up, and so interface is up, and our line protocol is up. Fantastic. Do a little exit, drops us back to the enable mode, which is where you're supposed to run these commands from. And we can do our show interface IP brief, or sorry, see I got it backwards again. Show IP interface brief, and we can see here we got both our interfaces, IP addresses are configured, and we have up and up. Easy enough. So what we need to do next is we're going to go ahead and do our copy run start. Always a great time to save your configurations. And we're going to put the router away for right now. So let's work on switch 1. And you'll notice actually, now that we brought that interface online, you'll actually see on the switch in this little CLI that it's actually told us that that interface has come online. And look, we got greens now across the board because we just brought it up from the router side. As I mentioned, the switch, by default, it's connected. It's going to function just the same. So let me grab that document again just to make sure we're getting everything we're supposed to. We're going to enter our privilege execution mode. We're going to go to global configuration mode. Hostname, switch 1. Cool. And then what we're going to go ahead and do is we're going to configure our interface VLAN 1, and we're going to configure our IP address on it, which is 10.10.10.2. And just for the sake of double checking, in case there's some other weird mistake here, yes, the switch is definitely 10.10.10.2. Perfect. Always good to double check the addressing, especially with the mistakes that we've seen here already. 10.10.10.2. We need to supply the subnet mask so it can determine what part of the address is the network and what part of the address is the host portion, which this is a /24, so it's 255.255.255.0. If it was, say, for instance, a /25 as an example, then it would be 255.255.255.128. And you just basically keep moving down the list, so to speak, adding them up. So that's done now. Let's do our no shutdown. Fantastic. Our interface is up and up, as it definitely should be. And let's just go shift over to this other switch over here. And we're going to do something very similar with it. We're going to enter our enable mode. We're going to go to global config mode with config T. We're then going to go ahead and attach a host name to this. So host name space switch 2 interface VLAN 1. Fantastic. And you'll notice, as I mentioned before, as you move through these different modes, you're going to see the prompt change. So right now we're in interface configuration, which is why you see the config-interface. IP address 10.10.20.2. Got that done. Got to bring the interface. Oh, no shutdown. See? Even I make mistakes here and there. Not shutdown, it's no shutdown. Interface has come online. That's fantastic. Interesting. See, this is actually an interesting bit. In the network portion, it tells us that this is actually supposed to be VLAN 2, not VLAN 1 on switch 2. But it also never talks about how to actually add the interfaces to the correct VLAN so it would actually function. So we're going to leave it on VLAN 1 and just assume that that's also a mistake in the lab. So let's go ahead and we're going to do the things we did before where we enabled the passwords and all that sort of fun stuff. So what we're going to do is we're going to go ahead and go to our line console, line con 0. Password is going to be Cisco, login, line VTY 015, password Cisco, login. And are we going to do a banner message of the day? There's not one there, but let's just do it anyways for the sake of unauthorized access. So banner MOTD hashtag paste. There we go. And funny thing, and part of the reason why I also did that as well, is now it actually drops me into the config mode, and from here I can do my enable secret class, and we can do our service password encryption from here. And let's go ahead on the other switch and do the same thing. So we're going to go and do our line console 0. We're going to enter in our password of Cisco. And we're going to do login. And then we're going to do our remote telnet lines 015. Password Cisco. Login. And then we're going to do our banner MOTD. Our delimiting character, which we're using the hashtag. It can be any character. The character just can't appear in the message. There we go. So now we actually have both switches VLAN set up. We got that. Banner message of the day. Oh, we almost forgot our secret. Enable secret class. And I'm going to check on that service password encryption because I'm pretty sure it has to fall somewhere in the lab. If it didn't, it's definitely something you want to do. And then we're going to go ahead and configure our default gateways. So in our global config mode, IP default gateway 10.10.10.1. Basically, we got to tell the switch how it gets outside of the network. So if I'm sending a package anywhere other than the 10.10.10 network, the switch knows I'm going to send that package to the interface on the router. And the interface on the router has an IP address of 10.10.10.1. Similarly, with switch 2, we're going to do the exact same thing. IP default gateway 10.10.20.1, because that's the interface on the router on this side of the network. Bang. So we're going to do that. And then we're going to go ahead and save our configs. So copy run start, copying the running config from the startup config, and over here we're going to do the same thing. We have to go back to enable mode, and we're going to do a copy running config to startup config. For those of you who are typing the full commands in, easy peasy. So next up, we are going to go ahead and configure the hosts. Easy enough. So let's close this off and let's close that off. So we got PC1. We're going to go to the desktop. We're going to go to IP configuration. And we're going to go ahead and configure it with 10, 10, 10, 10. And like I said, what you'll see is it's going to want to default out a subnet mask of a /8. But we don't want that. Because if you do that, it'll never go anywhere. Because your computer is going to think it's part of the local network. The switch is going to say it's not. And you're just going to end up with problems. Now, the one thing that it said, like I mentioned, that we don't need to do, but we definitely do, is we do need to configure our default gateway. What we don't need to do, however, is we do not need to configure DNS, because with our DNS, that only applies if we need to resolve something from a name server. So if I was trying to go to google.ca, I would have to then resolve google.ca to an IP address in order to send the traffic outward. We're not doing that. We need a default gateway, though, because any traffic that's sent from this PC to anywhere outside of its 10.10.10 network, and we know it's outside the 10.10.10 network because the subnet mask tells us that. Basically, these first 3 octets in our network, because of the way the subnet is saying this portion is our network, this last portion is our host. So anything that's not part of this host portion that's changed, it knows it has to send it to a default gateway. So that's why we're configuring that there. So let's go ahead. We're going to close that window. We're going to open up our PC2. We're going to do the same thing over here. We're going to go ahead 10, 10, 20 this time. 10. You're going to know the same thing happens. It's going to put a subnet mask in of a /20 or a /8. And we need a /24. So we're going to put in a 255.255.255.0, which is a class C subnet mask. And we're going to go ahead and configure our default gateway. 10.10.20.1. And then we're going to go ahead and close that off. So I think that's actually the end of this lab. Do we need to do anything else? configuring the hosts. Oh, we can go check the bits there. Yeah, why not? Let's go ahead and not the terminal command prompt. Let's do an ipconfig/all. Okay, fantastic. We can see we have our 10.10.10.10 network. We have our /24. We got our default gateway configured. There's no IPv6 configured. Fantastic. Let's go ahead and run our ping to our 10.10.10. And actually it wasn't 10. We're going to do 20.10. So it should hopefully fail the first time. Hopefully it doesn't fail all the times. Perfect. So this package now goes from here, goes through the network all the way over here. And if we throw this actually in simulator mode, we can go from the other side and hopefully see something exciting happen. So we can go from here and we can do a ping to 10.10.10.10. So let's go ahead, smack that play button. You can see that little packet being sent all along the way. It goes to the router. Router forwards it off. Goes to the switch. All right, let's just speed this up because I am busy. So you're going to know something different happening this time. See, we sent that package off. And if you notice, we didn't have a failure on the first time. And the reason why it didn't fail on the first time was because we sent a package from PC1 all the way through the network. And while the first one failed, by that point, the ARP tables had been built on the switches. So therefore, it knew how to get there, and it's not losing that first package. So our ICMPs are being zipped off. While that's happening, we see our dynamic trunking protocol and our spanning tree protocol from the switches, basically trying to build out the network and see what's out there in the world. And there we go. Isn't that beautiful? And this CDP, that's also a Cisco proprietary protocol. That specifically is. It's called Cisco Discovery Protocol. And it's used to identify network devices that are nearby. So let's go snap that back into real time. Now, in the case where pretending like something went wrong and you weren't able to get this to work, it could happen. So if that was the case, and say for instance you weren't able to get outside your network, well, let's do something here. Let's take this off, take this off. Let's take out our default gateway, close this. Is it going to let me close it like that? Perfect. So now that we removed the default gateway, let's try something out. Let's go back and hopefully I don't have to eat my socks. We're going to ping 10.10.10.10.10, and we should hopefully get a failure. Request timed out, request timed out, request timed out, request timed out. So we're going to get 4 failures. Reason being, like I mentioned before, it can't get its way outside the network. Now, a great thing to troubleshoot if you weren't certain why this wasn't happening, what you can go ahead and do is actually start pinging from what you can hit. So as an example, we know that we have a switch in the middle with the management VLAN. We also know that we have a router with an interface that we can hit. So let's just start hitting those. So first things first, we're going to go ahead and ping our 10.10.20.2. Let's see, does that work? I don't know, we'll see. Yeah, there we go, perfect. First one times out because it probably didn't have an entry for it in the ARP table. It has to send out a request, but it's on the same network, so life is good. Now let's go ahead and ping the next thing. So we know that works. We can do our ping to our 10.10.20.1. This should also work as well because that is part of our network, right? This interface on router 1 is facing into our network. It is one with us. However, if I go to ping outside of it, so I do a 10.10.10.1, let's see, will this fail? You never know, it may go through, but I don't think so. And the reason why I don't think so is because this computer is like, it's not part of my network. I don't know where you expect me to send this package. So it's going to come up with a request timeout, request timeout, request timeout, request timeout. So package goes nowhere. At this point, you might be like, well, it's easy enough. We can just go in there and fix that thing. One other thing you can also do as well is you can take your simulator, if you so choose, so to speak. I've never actually done this on this particular task, but let's go ahead and try pinging and seeing what happens. So let's smack the play button. It hits the switch. Basically what ends up happening is it just dies after that. It doesn't actually go through anywhere because it's not part of the network. Or it didn't even hit the switch. I don't know. It basically just sends it and it's like, yeah, not part of the network. Goodbye. Because if you remember, layer 2, it doesn't actually contain information to get outside of a network. So now it's in real time. Hopefully this takes less time to clear out. 1, 2. Perfect. So let's close this back off. We can go back in here. We can configure our default gateway. We can go back here. We can hit this. And then we can go ahead and try our ping again. And it should say successful because of the fact that we can get through there. Let's see. The other thing I was going to mention, if we go to our Ipconfig and we let it try to do this thing, let's actually see what happens. It kind of can create erratic behavior, so it actually very well may work. I don't believe it should, but you never know. Oh, wrong prompt. So let's see what happens when you ping it. Yeah, see, it's going to go through fine. But let's see what happens if I ping this one too. Yeah, see, it goes through fine as well. It's very specific cases where it would throw up an error, but long story short, you want to make sure that you're matching your subnet masks to each other, because when you start dealing with complex routing, or multiple subnets on the same network, so like router on a stick as an example, and the switch has multiple VLANs configured, bad things can definitely start happening if you don't watch your subnets. That more so happens when you start getting into access controls as well. But yeah, so that gets configured, and we can double check that. That's fine. Cool. We can come over to our switch. We can do a little ping. So we can do a ping to 10.10.2, which, if I recall correctly, should be switch 1. Oh, it failed. Oh, no, it didn't. It went through. Perfect. It just, a few of them failed. There we go. Success rate 100%. It took some time for it to build up a table to how to get there. But if we go to switch 1 and we try that, ping 10.10.22, that one's going to be successful because we wasted all our stuff off before. Similar, you can open up your router. So we got to type in our password. A lot of people had issues with this because it doesn't actually show what you're typing, but trust me when I say it, it does type what you need to do. We're going to go to enable mode. And, almost showed my super secret password of Cisco in class. What we're going to do, actually, I want to just show something else. We're going to do a show IP route, I believe is the command. Yes, perfect. So if we show our IP route, basically what we can see is we can see our different networks we have configured. We have our directly configured network we got here, which is 10.10.20.0. And we have our other local connected network, 10.10.10, on our other interface. And specifically, we have our interface IP address, which is loaded in here. That all happens automatically. This area is something you're definitely going to be playing around with a lot more when you start dealing with routing. But we can also go ahead and do our pings from here as well. So 10.10.10.10, success. And we can do our other ping, 10.10.20.10. And we got success as well. All right. Well, that's the end of that part. Let's see. What else is part of this lab? there's some questions at the end of it. Differentiate user mode from privilege mode. Oh, that's easy enough. So this is user mode. This is privilege mode. Let's see. Is there a help thing? Oh, no, I shouldn't have done that. I shouldn't have done that. Now you gotta wait. This is the most annoying part. Sometimes you can smash these things to get to quicker, but, well, now while that's figuring out about its life, let's go over to this other switch. Perfect. There we go. So if you put a question mark here, you can see what you can run from this user mode. Basically, you can put a terminal connection, you can turn on and off privilege commands, you can disconnect stuff. You can enable the privilege commands. Cool. Enable, disable. So I take go backwards. How you exit out of executive mode, which is exit, log out. You can send your pings. You can do your probably basic shows is my guess. Let's just see. Yeah. So pretty much what you can do is you can basically type in a command, you throw in the question mark, and it will show you information you can choose from that particular command. So if we go to our enable mode, type in our super secret password, and then we do our question mark. So you can see you got a lot more commands to choose from, right? The fact you can copy and move things around, you can get into global configuration mode from here. So a lot more management tasks that can happen from user mode than privilege mode. Half duplex, full duplex, that was already discussed in class during the switching week, but full duplex basically means that it's bidirectional communication. It can transmit and receive at the same time. Half duplex, you can only transmit or receive. Good example of half duplex would be most Wi-Fi connections. If you have a hub rather than a switch, hub is a half duplex based device, meaning that you can't transmit and receive at the same time, which means then that they deal with some sort of management of traffic jams, so to speak. So some of them is carrier send with collision avoidance, and some of them is carrier transmission with collision detection. And if there's a detection of a collision, then what ends up happening is it will basically put in a jam signal, which causes all the devices to back off at a random interval, and then they can start transmitting again. Benefits of VLANs. See, that's very interesting because the lab didn't actually really do anything with VLANs, like I mentioned before. But is there anything? Oh, yeah, there's actually a file here at the bottom. Let's see what's actually in this particular website. How to configure VLANs. Yeah, it's very interesting. But they definitely don't get you to configure them. Because, like, here, I'll show you an example. If you show VLAN, you can see all of the interfaces are actually inside of the default VLAN, the one that's been configured. They haven't been changed. Like, if you wanted to change them, sure you could, but they just haven't been, so that's why it's kind of interesting that they would do that. But one of the big benefits of VLANs is you can segment traffic from each other, so you can have multiple bits of traffic on one single switch, and it basically segregates the broadcast domains. So your as an example, pin pads can be on one network on a switch, or on one VLAN on the switch, so to speak, and then you can have your printers and you can have other devices, and they're all going to be happy in their own little land, but you can't have things talk between VLANs. So if you had a PC on VLAN 1 and this PC over here was connected to the switch on VLAN 2, the two of them wouldn't be able to directly talk to each other unless you were dealing with some sort of other additional bit like, router on a stick or something. But definitely, I would say read into the VLAN bit. And then the other question is, what is subnetting? Subnetting is just basically breaking down networks. So that's an easy enough thing to explain. So if I was to take this file and chuck this over here, well, let's click on Edit and go all the way to the wee bottom. So if we look at subnetting, as an example with this particular network they provided to us, we said it was 10, 10, 0, and it was a /24, and they also gave us a 10, 10, 10, or 20.0. That's a /24 as well. So what that means to us, like I said, I've been saying for a little while now, is that basically we have to look at the maximum number of hosts that are available to us. And if we look at a /24, well, as I mentioned before, a /24 has a subnet mask of 255.255.255.0, and this has a subnet mask of 255.255.255.0. Which is basically the same thing as saying, this has 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0. And then we look at our this. Well, what is this going to be? Well, if we're looking at a 10, it wouldn't be a 128 we need. We don't need a 64. We don't need a 32. We don't need a 16. We do, however, need an 8. And then, do we need a 4? No. Do we need a 2? Yes. Do we need a 1? No. So there's the first digit, and then we just do the same thing again. 1, 2, 3, 4, 1, 0, 1, 0. And then we go 1. So we don't need a 128, we don't need a 64, we don't need a 32. We do need a 16, however. We don't need an 8. However, we do need a 4, and then we don't need the last bit. And then we don't need that last one as well. So we don't need a 2 and we don't need a 1. And then we do our 0. So let's just key that over there like that. So what we end up having now is we've kind of broken this IP address down to binary. And you might ask yourself, why the hell am I doing that? What's the whole purpose behind it? Well, the whole purpose behind it is so that you can subnet and do stuff. So I'm going to kind of kick this over here. And just as a reference, if you're ever doing subnetting, basically it's 128, 64, 32, 16, 8, 4, 2, and 1. So that's kind of your binary representation. So what happens is if you take all of these and add them together, that's the maximum number of hosts that you're allowed on your network. So the whole point behind subnetting is that way you can kind of chunk out your network and conserve your address space. Because, if we didn't deal with subnetting, and it was an issue, and that's why we have IPv6 now, in IPv4, the maximum number of addresses that are available is basically 2 to the power of 32, which, you might think is a large number. However, when you actually break it out, it's actually only 4.2 billion addresses. So not very many addresses to work with. So we need to sort of do different subnetting styles, and sort of the grand scheme of things, everything gets broken down into a few different subnets or default subnets. We have our class A, class B, class C, and then there's a couple other ones afterwards, but those are typically the only ones that you really are going to ever deal with. So a class A is a /8, a class B is a /. Class A is a /8, class B is a /16, class C is a /24, and respectively they're subnets would be like that, and this one would be like that, and this one would be like that. And then, as I kind of mentioned before, there is subnets beyond that, but typically you're not going to be really experiencing anything there. The idea behind subnetting is that you're not wasting, gargantuan amounts of, hosts, right? So you ask yourself, why were we using a /24? Well, we really only needed one PC. It still is a huge waste, right? Because if you think about it, well, if we look at a class C, and we can adjust this one thing, so we have basically 256? If we had a /24. Host bits, we have 8. So usable hosts, we would actually have 254, because it's actually 2 to the was it Control Shift 2 to the n minus 2, basically. Well, that was a terrible idea to go into that, because I don't know how to get out of it. Basically, it's 2 to the n minus 2. And the reason being is because you can't use your network address as an IP address, and you can't use your broadcast domain as an IP address. So you lose a couple things there. But yeah, so basically you just sort of work down them. So when we have that, if we look at the other one, so instead of having 8 host bits, you would have 16 host bits. Well, if we have 16 host bits, let's move that through. Sorry, I'm just going off camera and I'm just doing the calculations because it gets a little chaotic. Class B has 16 bits. So basically we have 65,534, which is kind of cool. And if we do a class A, basically we end up getting stuck with even more addresses. So you thought 65,000 was a lot, but this, we actually have class A. We have 16, 2, 3, 2, 4. So that's how many hosts per network we have in a class A. So like if you were on campus as an example, you're more likely to come across like a class A because of every single device that's on the network. And you might say, well, that's a lot of devices. But when you think about it in the grand scheme of things, well, every single student that's on campus using a computer, if you have a smart device, you have a tablet, well, that's 3 devices as an example per student. If you plugged into an Ethernet jack instead of using Wi-Fi at one point in time, well, now that ties up, 4 IP addresses for them. If you have phones, well, every phone in the school has an IP address. You have wireless access points. Every wireless access point has an IP address. Every printer has an IP address. Anything that's on the network has an IP address. You can sort of segment this, into to smaller bits and stuff like that. But yeah, there's lots and lots and lots and lots of stuff to know about these. And by all means, this is just the cusp of subnetting. It breaks down a lot more. And if you look at the default classes, so when we typed in that one IP address, it tried to default itself to a class A, and the reason being is because the first octet was between 0 and 126. If we looked at a class B, basically we were looking at a 128 to 191. If we were looking at a class C, we'd be looking at a 192 to 223. Doesn't mean you can't do, variable length subnet masks. but if you're just dealing with the default classes, a class A is 0 through 126, 120 is there. And you might ask yourself, hold on a second, what happened to 127? Well, 127 is your loopback address, right? So you can't use 127. This is a loopback. So if you ping 127.0.0.1, you're basically just pinging your own IP stack. And as I mentioned before, there is other class addresses, like as an example, you have a class D or you have a class E. However, those aren't things we're going to be dealing with anyways right now. So that's kind of just a quick, down and dirty, so to speak, on this topic. Let's just see if anybody ended up joining and posting any questions. YouTube. Oh, perfect. No questions. So with that being said, I'm going to chime off. As always, I do try to run these once a week, usually on the Monday or Tuesday, so feel free to pop in and watch if you have questions.